Hey, seventh grade, we're going to look at some two-step equations today. This is a little bit different from the one-step equations we're used to, but I think you'll find with a little bit of practice, it's not so bad. So you can see I have on the screen a tape diagram here. I've got a piece that is worth 26, and then I've got 4 equal pieces that are worth x. And we know from our one-step equations that when we see 4 pieces that are all the same size, we're saying x plus x plus x plus x, or 4 times x. So we can think of this as 4 times x plus 26, and that's equal to the whole worth, which is 46 in this case. So I wrote the equation over here. Now, if I literally had a piece of tape and I knew it was 46 centimeters long, and I had a 26 centimeter piece on the end, but I wanted to find out how big these little pieces were, the first thing I would want to do is find out how long are the 4 pieces all together. And I can find that out by taking my 46 and subtracting 26. So that's what I'm going to do. I'm going to subtract 26 here. And when I do that, I end up with 20. And that's what just these 4 x's are worth. So if we wanted to look at it algebraically, in order to make sure I'm keeping track of everything, I'm going to subtract 26 from over on the right side too, because it's just the 4x that's equal to 20. So I end up with 20 on the left side, 26 minus 26 is 0, and then we just drop that 4x down. So now I know that 4 times x is equal to 20, and I think from here it's pretty easy to see what x is equal to. But if we had something like fractions or decimals, something that wasn't so easy to figure out using mental math, we would want to undo the operation that's being done here. Just like these were being added, so we subtracted them to find this distance, we would undo the multiplication here by doing its inverse. We would divide by 4. And when we do that, 20 divided by 4 is 5. And 4 divided by 4 is 1. That simplifies to 1. You might have heard some math teachers say that that cancels, but really what they mean in this case is that that simplifies to 1. And we know that when you multiply something by 1, it's just itself. So in this case, 5 is equal to x. First, we subtracted our constant, then we divided by our coefficient. Let's take a look at one more example. So here we have a tape diagram, and it has 4 pieces of tape all equal to each other, all labeled x plus 9, and they are set equal to a total of 76. So if we were to write out what equation was being represented here, we would have a 4 out front representing our 4 pieces of smaller tape, times x plus 9, because that's how much each small piece of tape is worth, and the whole thing is equal to 76. Now, looking at that, it's kind of difficult to figure out what is x? I'm not really sure. So we've got a couple things we can do. Number 1, we can apply the distributive property. We know that we can do 4 times x and 4 times 9. So 4 times x is just 4x, right? We don't know what x is, so we leave it as 4x. There's a plus sign here, so we keep our plus sign. And then we've got 4 times 9, which is 36. And the equal 76 was not affected by the distributive property, so we just rewrite it. Now we have an equation that was a lot like the one on the previous slide, where we've got a constant and a coefficient. So the first thing we need to do, we would subtract our constant. And we want to do that from both sides of the equation, otherwise we'll be accidentally changing the equation, and we don't want that. So 36 minus 36, those are additive inverses. That gets us to 0. That's another thing a math teacher might call canceling. I'm going to draw a line here to help me keep track, make sure that I'm doing the same thing on both sides. And then 76 minus 36 is 40. So that gets me 4x drops down. That was not affected by the adding or subtracting. Why? Because they're not like terms. One had the variable x and one did not. So 4 times x is equal to 40. And again, mental math tells us we know what x is. But if there were a decimal, if there were a fraction, something a little bit more complicated, then we would undo the multiplication here. We would do its opposite. What is the inverse of multiplying? It's dividing. So again, we're dividing by 4. And when we do that, 4 divided by 4 is 1. So some math teachers might say that will cancel. I'm going to say that simplifies. So we get 1x. And then 40 divided by 4 is 10. So now I know that 1x is equal to 10. And if we were to check that, we could sub this in and say 10 plus 9 is 19. 10 plus 9 is 19, 10 plus 9 is 19, and 10 plus 9 is 19. So if I took 19 and I added it to itself 4 times, I would end up with 76. Now, there's another way to do this. Let's say I'm still struggling a little bit with distributive property. It's not my strong suit. We can work around that. If we know that 4 pieces of tape are worth 76, we could figure out what 1 piece of tape is worth by dividing it by 4. And when we do that, 76 divided by 4 is 19. So that tells us that 1 piece of tape, one of the smaller pieces of tape, is equal to 19. Now we have a one-step equation. X plus 9 equals 19. And we can solve those in our sleep. We've been doing that since last year. What is the opposite of adding 9? The inverse, subtracting 9. We could also say adding a negative 9, right? It's the same thing. Subtract our 9. And x is equal to, yet again, the number 10. So there's 2 ways to solve when you have distributive property. You can either distribute or you can divide it out. It's up to you. Go ahead and start on that IXL. If you have any questions, you can find me on GoGuardian or shoot me an email.